electronic configuration. Electronic configuration is nothing but the arrangement of, take down, arrangement of electrons in an atom around the nucleus in various energy levels or orbits or shells. Let me consider chlorine. Its atomic number is 17. So this 17 can be organized like this: 1s2, 2s2, 2p6, 3s2, 3p, 2 plus 2 4 plus 6 10 plus 2 12, and you can put 5. So it means in the third shell you got 7 electrons, totally 17 electrons. Now this s, p and d, f, these are all orbitals, and 1, 2, 3 are called shells, that is orbits. Orbits in those period they were called shells, which is nothing but the two-dimensional electronic path, that is two-dimensional path traveled by the electron. Orbital means it is a subshell, that is within the shell it is available, so that's why it's called subshells. And this is the three-dimensional space within which the probability of finding the electron is maximum. And in the case of orbits or shell, we have first shell, second shell, third shell, fourth shell, fifth shell, etc. And they were represented by letters also, like K shell, L shell, M shell, N shell, O shell. In fact, in each orbit we have 2n power 2 number of electrons, where n is equal to 1, 2, 3, 4, 5. And in this case we have 4 types of subshells, that is orbital: s orbital, p orbital, d orbital, f orbital. In the first shell we have only s orbital. In the first shell, that is K shell or 1, first shell, we have only s orbital, so you can represent this by 1s2. In the second shell, that is L shell, you have 1s2, 2s2, 2p6. So we have got already a formula 2n squared, is it not, for orbit? So 2 into 1 squared is equal to 2 electrons. In this case 2 into 2 squared, that is 8 electrons. And M shell, where we have 3. So 3s2, 3p6, 3d10. So s electron can have maximum 2 electrons. P orbitals can have maximum 6 electrons. D orbital can have maximum 10 electrons. F can have maximum 14 electrons. So till which we can substitute with these electrons. Now let us consider, and what about this? 2 plus 6, 10 plus 18, that is 2 into 3 squared, that is also 18. Are you able to understand this? Clear? And similarly we can proceed with n shell, that is the fourth shell, where you can represent this as 4s2 4p6 4d10 and then 4f, okay, 14. It means how many electrons it can accommodate? 2 into 4 squared means 32. 4 fours are 16 into 2, 32 electrons it can accommodate. Are you able to follow? Similarly, we can proceed with O shell, that is fifth shell, where you can have 5s2, 5p6, 5d10, okay, and then we have this 4 of 14. You just count it, 2 plus 6, 8, 8 plus 10, 18 plus 14, 32. So we will have more complicated orbitals here, 5f. Okay. So it is understood that is at least you should know up to n. Now let us consider, and how much you expect here? 2 into 5 squared means 20. 2 into 5 squared means 5 squared 25 into 2 50. So likewise it goes. Now let us consider the same chlorine, Cl17. We already represented this by, that is 1s2, 2s2, 2p6, 3s2, 3p5. Why I have stopped with 5? Because we have got only 17 electrons. How I organized this? This is based on Aufbau principle. And what is this Aufbau principle? How to construct the electron with the increasing order of energy. So here you have 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 4f14, 5s2, 5p6, 5d10, 5f15, 14, etc. Now you can have the order of increasing order of the electron, that we can indicate like this. First you can write down 1s2, I have given 2s2, so in the same direction you should write 2p6 3s2, 2p6 3s2. After that you should go to what? 3p6 4s2, but you cannot put 3p6 because you have got only 17, so 3p5, and that is the last shell. And likewise let me have this iodine. What is iodine? Iodine is, what is the atomic number? 53. Now let us try this. 1s2, 2s2, 2p6, and then 3s2, then 3p6, okay, and then 4s2, then after that 4s2, then 3d10. Are able to follow? 3d10. Now can you find the change here? After 3p6 it should go to 3d10, but according to Aufbau principle it fills up this 4s2 and come back once again to 3d. So 4s2, after that 3d10 and again 4p6. 4p6, then you have 5s2. Now you can put 6s2 also here. Okay, now you can draw like this. After 5s2 it comes across like this. Okay, now after 5s2 go to 4d10. So 4d. Now you just remember, meanwhile you had to add the electrons also. 2 plus 2 4, 4 plus 6 10, 10 plus 2 12, 18, 18 plus 2 20, 30, 36, 36 plus 2 38. So we can accommodate 10, 48, balance 5. Is it not? 48 plus 5, 53. So we have come up to 4d10. Now you can go to 5p6. Okay, or you will follow. After 4d10, 5p6. Okay, so how much we can write? Only 5. Even though it has got 6, but we can take only up to 5 electrons here. Okay, now you can work out 1s2. It is in the first shell you have for iodine. How much? 2 only. In the next shell you have 2 plus 6 8. In the third shell 2 plus 6 8, 8 plus 10 18. Are you able to follow? In the fourth shell 2 plus 6 8, 8 plus 10 18. Are you able to follow? And then 2 plus 5. I hope in the first shell you will be able to understand why I have put this 7. Now is it clear? Okay. It is because of this zigzag arrangement. See, after completing 3p6 it should go to 3d10, but what Abba principle says, you have to follow this. So accordingly 3p6, after that 4s2 is filled up, then comes back to 3d10, then 4p6, then 5s2, and then once again 4d10, then come back to 5p5. Okay, so if you strictly follow this diagram according to Abba principle, you will get the correct electronic configuration. Clear? Are you able to understand about electronic configuration? Can you write the electronic configuration of iron? 26. Try. We'll try the electronic configuration of iron. How to represent iron? Fe. What is the atomic number?
26.
26. Now shall we try? 1s2, 2s2. You can side by side you can see 1s2, after that 2s2, then 2p6, 2p6, 3s2, 3p6, and then instead of going to 3d10 you should fill up the 4s2, then come back to 3d. Now meanwhile you can count the number of electrons also, so that it should match with the atomic number. Okay, so here 2 plus 2 4, 10, 12, 18, 20, so 6. So the final shell should have 6 electrons here. Okay, so here the order of filling will be like this, but the position will not be changed. Okay, it means the fourth shell is always in the fourth stage only, but when you fill up, it will have the priority here and then come back. So we can rewrite this as 1s2, 2s2, 2p6, 3s2, 3p6, and then 3d6, then 4s2. Are you able to understand? So now you can understand this is the K shell, that is the first shell that contains 2 electrons, and 2p6, 2s2p6 is the L shell, which is the second shell, that is 8 electrons, and this is the third shell, M shell. This is the third shell, where you have got 2 plus 6, 10, 14. Okay, 14 only. And here it is 2. And this is n shell, that is 4th shell. Usually we have to fill up these two. Actually, that is, it should be written as 3D8. But according to Abba, you have to fill up this and come back. Okay. So when you write the electronic configuration by box model, you can write like this. For example, 1s2, you can put one box with parallel spin and anti-parallel spin. This is 1s2. And 2s2 means you have 2s2, 2p6, is it not? So 2s2, 2p6. You can write 1, 2, 1, 2, 3, 4, 5, 6. And for third shell, you can write 3p, then 3p3, and then 3d. Okay, 1, 2, 3, 4, and 5. Because we have got 5 shells. So you can write 3s2 means 1 electron, 2 electron. 3p6 means 1, 2, 3, 4, 5, 6. So you should fill up the electrons in this way only, according to, that is, Hund's rule of maximum multiplicity. The electron pairing will not take place actually in this case. So you should try to attain all the equal energy level, then only what? The pairing takes place. Till then, so it is the tendency of the electron to, that is, spread as much as possible in the same energy level. And in this case, now as I already mentioned here, that is 4s2, is it not? So you can mention only one. So this is 4s2, it is filled up and then come back to here. So the remaining is what? Only 6 electrons. So you can put 1, 2, 3, 4, 5, 6. Now you can tell how many unpaired electrons here? 1, 2, 3, 4. So these are all unpaired electrons. So 4 unpaired electrons. These 4 unpaired electrons can easily bind to other elements to form a bond, and that is why they are called bonding electrons. Take down. They are all called bonding electrons. Whereas in the same shell, that is, according to d orbital, you have how many electrons in the third shell? That is one pair of electron here. It is the lone pair of electron. It is kept alone, non-bonding electron. So this is the non-bonding electron, and this is also non-bonding, 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 and this is the innermost orbital non-bonding electron. They don't involve in the bonding, and that is why those pairs, that is lone pairs, are called non-bonding electrons. So what is NBE? Non-bonding electrons. Okay, they are also called a lone pair because they are kept alone. So lone pair of electrons, right?